We're Group 3 and today we will be showing you Experiment 6 or Slump Test. I'm Yali.
Hi, I'm Meg.
Audrey.
I'm Evan.
And we're the
Group
3! Slump test is an on-site or laboratory type of test that determines the measurement of the consistency of concrete. It shows an indication of the uniformity of concrete in different batches wherein the shape of the concrete slumps can be used to show the information workability and quality of concrete. Slump is a measurement that identifies a concrete sample's consistency and predicts how fluid the finished product will be. It can help predict strength and give you an idea of workability by letting you know how simple or difficult it will be to place something. In this experiment, the standard reference used is ASTM C143, or the standard test method for slump of hydraulic cement concrete.
So let's move on to the materials and apparatus used in the slump test. The first one is a tamping rod. It is made up of a straight steel bar of circular cross-section. It has 16mm diameter, 600mm long with both ends hemispherical. We also have a mold, or also known as a slump cone. A mold in the shape of a truncated cone with an 8-inch base diameter, a 4 inches top diameter with a height of 12 inches. So it is used to make a specimen of freshly mixed concrete for the slump test. So the inside of a cone needs to be smooth and clean, and the cone must be free of dents and deformations. We also have a slump plate. It must have a clean level surface with no grooves, or indentation. If it has clamps, they must be able to move freely and be fully released without moving the slump cone during the test. So the next one is a sampling tray. A 1.2 by 1.2 by 50mm deep made from minimum of 1.6mm thick non-corrodable metal. Next one is a scoop. It must be large enough to get a representative scoop of concrete and small enough to where you don't spill any concrete on the ground as you are pouring concrete into the cone. The sixth one is a ruler or measuring tape. It must have markings at the 1/4 inch mark or smaller. Must be at least 12 inches long. The next one is a trowel. It is a small handheld tool with a flat and pointed blade that will be used to place the concrete sample into the mold. The next one is a stopwatch. A stopwatch is used for the duration of an event. It is a type of watch that is notable for the precision and accuracy with which it can measure the time of an event. We also have bucket of water and rag. It is used for cleaning your equipment before and after the test. And lastly, we have the PPE or personal protective equipment. When working with laboratory hazards, PPE, which is appropriate for the work conditions, must always be worn. Coats for laboratories or other protective clothing such as aprons, gloves, scrubs, and coveralls.
So we are going to continue with the procedures.
For the mixing procedure, first, mixing platform. Clean and watertight platform should be used for mixing concrete. Construct a platform of bricks or lean concrete or iron sheets of a size as per requirement of the volume concrete to be mixed. Second, mixing of cement and sand. Spread out the measured quantity of the sand uniformly on the mixing platform. Dump the cement on the sand and distribute it uniformly. Mix the sand and cement with the shovels, turning the mixture over and over again until the uniform color. Third, mixing of CA with cement sand mix. Spread out the sand cement mixture once again uniformly on the mixing platform. On top of this, spread the measured quantity of coarse aggregate. Don't dump at one place, otherwise the bigger particles tend to roll out. Mix again at least 3 times by shoveling the center to the side, and then back to the center and to the side again. Fourth, addition of water. Make a depression in the middle of the mixed pile and pour slowly into half 3/4 of the total quantity of water required. While the material is turned in towards the center with shovels, add the remainder of the water slowly, turning the mixture over again until the color consistency are uniform throughout the pile. This will indicate that the ingredients are thoroughly combined.
So now let's proceed to the procedures of the slump test. This is an important part of the laboratory test since it will determine what is the kind of slump that we will achieve as we go in our process. The procedures of the slump test are as follows. First, the internal surface of the mold must be cleaned carefully. Oil can be applied on the surface. For the second step, the mold is then placed on the base plate. The base plate should be clean, smooth, horizontal, and non-porous. Secure slump cone to the base plate using the cone tabs or by sanding on the footholds. Always remember that the cone must remain still throughout the test. Third step, using the scope, fill 1/3 of the cone with a concrete sample. Rod the material 25 times with a steel tamping rod, taking care to distribute rodding evenly over the entire cross-section of the sample. While rodding, you may touch but do not hit or thump the base plate. The diameter of this steel rod is 5/8 inch and is rounded at the ends. The tamping should be done uniformly. For the tip, a good technique is to angle the rod to match the slope of the cone and rod starting with the perimeter. Continue in a circular pattern, working your way to the center. Fifth, fill the cone to 2/3 full. Rod the second layer 25 times, making sure to penetrate the previous layer by about an inch. Continue rodding in a circular fashion, working to the middle, the same pattern as discussed in step 3. For the final layer, fill the cone to slightly overflowing. Rod the final layer 25 times with rod penetrating, but not through the second layer. Distribute rodding evenly over the entire cross-section of this layer. If the molded material sinks below the lip of the mold, stop rodding. Refill, then continue rodding, picking up where you left off in the 25-stroke count. After filling the mold, excess concrete should be removed and the surface should be leveled. When the mold is filled with fresh concrete, the base of the mold is held firmly by handles. Next, then the mold is lifted gently in the vertical direction and then unsupported concrete to a slump. Holding the cone firmly, unlock or step off the cone tabs. Slowly lift the cone vertically in a steady motion without any rotational movement, straight up to clear the sample. The lifting should take 5 to 10 seconds. The decrease in height at the center point is measured to the nearest 5 mm or 0.25 inch, and it is known as slump. Lastly, place a straight edge, preferably the tamping rod, across the slump mold base, with one end suspended over the pile of concrete. Using a tape or ruler, measure the distance from the bottom of the straight edge to the displaced center of the slump concrete. Finally, record your results to the nearest 1/4 of an inch.